Hello there, exercise 2C, more vectors basically, and we're looking at straight lines, and straight lines in 3 dimensions. Straight lines in 2 dimensions are really easy when you're considering what we're doing today. And what we're doing today is basically parallel, intersecting, or skew lines, and there's a new word you possibly have never come across. But in 2 dimensions, this is pretty straightforward stuff. You might get 2 equations given to you, y equals 3x plus 5. And you might get y equals, I don't know, 2x minus 1. And that question says, are they parallel or not? And this is fairly straightforward. Don't know what happened there. This is fairly straightforward just because of the fact that the equations are so straightforward and familiar. We're used to this idea that if they have the same number of x's, then they are going in the same direction. They are parallel. And as these don't, it's a big fact. No, they're not parallel because 2 is not equal to 3 effectively. And if they were both the same number, then they would be parallel. But in 3 dimensions, it's a bit more complicated than that. I've got 2 lines here. These lines obviously do intersect. These 2 lines are obviously parallel. The weird thing is, in 3 dimensions, there's a third option. And we're going to look at mainly at 3D cases today. So a little starter for us. The points A and B have coordinates 2, 1, 4 and 1, 0, minus 4. Find a vector equation of the line passing through A and B. Well, first of all, you need a direction vector. And the easiest way to get the direction vector on this, part 1, the direction vector, do one vector minus the other one. I don't care which one we do. We'll do that, take away that. So 2 take away 1 is 1. You could have done the other way around, in which case it would be minus 1, but just stick with what you start with. 1 take away 0 is 1. And 4 take away a minus 4 is actually 8. Now that's quite a good little vector because they're all positive. They would remain in negative. I might change all the signs because it doesn't really matter which way around you do it. But anyway, that's my direction vector. My R now is easy. I pick a point on the line. Which one? Well, usually I always write the first one. 2, 1, 4. Plus lambda, or any letter, 1, 1, 8. Make sure it looks like an 8 and get the mark. Thank you very much. Explain whether this point goes through this point minus 3, minus 4, minus 5. Well, it might do. We basically sub that into there. And we go, well, if that's true, then my top line would be from here. You can think of this as the minus 3, minus 4, the minus 5. My top line equals 2 plus 1 lambda. Equals 2 plus a lambda. The second one would give me minus 4 equals 1 plus a lambda. Oh, there you go. I've got 2 simultaneous equations. But actually, they are simultaneous, but they don't need to be. I can solve both of these 2 equations. And if I solve this equation, I get that 2 moves over. This gives me lambda equals minus 5. This one gives me lambda equals minus 5. Now, if I get the same thing on the last one, then I'm sorted here. So what's that say? It says minus 5 equals 4 plus 8 lambda. This doesn't look like it, does it? So this implies that 8 lambda equals minus 9. Lambda is minus 9/8. So straight away I know not on the line for that reason. And yeah, I said no, I haven't shown any working out. Whereas I have here. And in an exam you would need to show working out. You'd need to show those lambda values. So if we have 3 intersecting lines, as I say, they might intersect, they might be parallel, or they might be something else. 2D, no problem at all. 3D, they could be parallel, they could be intersect, or they could be skew. Now I want you to have a look at this. This is actually a graphical package, so I want to try to get you to understand what skew means. So on this I'm able to, in here, type in an equation. So I want you to see this. I've already entered one equation of a line here. It's a straight line, but as you can see, the great thing about this package I'm using here, you can rotate it. And the equation I've got, if I show you it, it says down here, x, y, z equals, well, that means, well, r is 2, 1, minus 1 plus lambda 1, 2, 3. That's actually what I typed in. I'm going to type in another one. So this one, I'm making this up. I have no idea what I'm doing. So this time I'm going to say it's r, or x, y, z, as this says. I'm going to do 1, I'll do 0 and 2. And then it will be 0, 3, Well, there, there. So I've no idea what those lines look like. Oh, it's there. Oh, right, it's there. Now, can you see those lines? Now, they look as if they'll cross, but then what you realise is actually they're in 2 dimensions, and they are missing. One seems to be above the other. Now, that's not to say they're always missing. They're not parallel, these lines. You can see there, for instance, it seems to be missing. It seems there as if they cross, but of course, when you see it from this angle, you can see they're definitely missing there. I think they are always missing those 2 lines. Yes, look, they don't seem to cross those 2 lines. So the red line doesn't seem to hit. Even that looks as if it does, until you do that. You think, oh, actually, no, it did miss by quite a long way. Now, these would be an example of 2 skew lines. So that's what skew means. So we need to understand what is meant by these 3 words. Parallel, they go the same way. Intersect, they cross. Skew, they miss. Now, this is an old style picture of what we used to always do in maths where we didn't have the posh software. And these are meant to show 2 intersecting lines, 2 parallel lines. And these ones where this sits in this what we'd call a plane, which is different from this one. And it intersects the plane at a point which is not hitting CD. Now, so this is what we need to be able to do. We need to look at some lines and determine, are they parallel, are they skew, or do they intersect? So first thing to do, I always look at parallel. Look at them. Are they parallel? Now, parallel, that means one vector is a multiple of the other vector. Multiple of the other vector. So essentially that means if you take one vector and you multiply it by a set number, I'll write u equals k times v, where u and v are the vectors. So if I can take k and multiply it by that k by the vector, and I get the other vector, then I'm sorted. So look at this. These are my direction vectors. We always look at the direction vectors. So I've got d1 equals 1 minus 2 and 5. And d2 from the other one, d2 equals 2, 3 minus 1. But you can see from this quite quickly that if I double the first one, I get the second one. But if I double the second one, they're not. So I'd write d1 is not equal to k times d2. Therefore, not parallel. They would need to be parallel if they were a multiple, and they're not a multiple, so they're not parallel. Now, do they cross? That's the next point I'm going to effectively do. And to get that, I basically do the top line trick that I've done in the past. I write, well, my x is my minus 1 plus my lambda. Notice I've done this. If they intersect, it must hit this. So I'm going to say that is equal to 5 plus 2 mu. This is my x done. And now I do my y equation. I say 3 minus 2 lambda has got to equal minus 2 plus 3 lambda. And effectively this gives me a minus 2 plus 3 mu even. I get there eventually. And these give me 2 simultaneous equations, which I'm going to chuck into my calculator and get out from it what lambda and mu is. Now I've got to do a little bit of work because let's face it, they're not usually written like this. So if I move my I'm going to move my mu over there and my 1 back here. So I'm going to write lambda minus 2 mu, I reckon, equals 6 when I rearrange that. And this one's minus 2 lambda. Keep the order the same. Minus 3 mu equals minus 5. Now, actually, you could make them all positive, but my calculator is brilliant because it will just do this for me. So I'm going to say top equation 1 minus 2 and 6. They're the coefficients of the 3 terms. Next one says negative 2, negative 3, and negative 5. And you just let it do the work. So it tells me that the first one, it says x equals, but I know it's lambda equals 4, and mu equals, the second one, don't know what that is, minus 1. Mu equals minus 1. It says y equals, but I ignore that. Now, look, if I now substitute this into my bottom equation, I should get the same on both sides. So 2 plus 5 mu, lambda, sorry, equals 2 plus 5 times 4 equals 22. So going into the left-hand side, if like, is 22. But let's go on to the right-hand side. It's 1 plus a mu. In fact, it's a minus mu. Let's get it right. So that's 1 minus a minus 1. That's definitely not 22. So therefore they're not. They don't intersect. They don't intersect. They do not intersect. I'll try and write it properly. If they do not intersect, they must therefore be skewed. Because are they parallel? No. Do they intersect? No. They must therefore be skewed. Therefore they're skewed. And I've got the same thing. 22 is equal to 2. Well, no, it's not. Explain how you know these are not parallel. Well, I'm going to guess. Yeah. D1 equals minus 4, 1, 0. Always look at D1. Look at D2, 2, 1, 2. Can you write one as a multiple of the other? No. D1 is not equal to KD2. Therefore, not parallel. Sometimes they are parallel. It's the easiest question in the world. Now I say, well, let's see if they intersect or if they are skew. It says show that the two lines do in fact intersect. All right, and it tells me what to expect. 1 minus 4 lambda equals 9 plus 2 mu. That's the top line. Second line, the y line, gives me 1 plus lambda equals 2 plus mu. You might as well do it the same way every time. Minus 4 lambda minus 2 mu equals 8. If I rearrange, lambda minus mu equals 1. So what does lambda equal? What does mu equal? You just do these the same way every time. So my calculator is set up for it, so I can just type this in. So negative 4, negative 2 and 8 and 1 and negative 1 and 1. It says my x, or my lambda in my case, is minus 1. And my y, or in my case mu, is minus 2. I sub those into the bottom line. My bottom line says R1 equals, well, in my Z line you could call this, couldn't you? So you say minus 3 plus no lambda, well that's equal to minus 3. And 1 plus 2 mu is minus 4, so that's 1 plus a minus 4 equals minus 3. Yeah, look, the same number. Ding ding, tick. Therefore they are intersecting. Now it wants me to find the coordinate. Well, all I do is I take one of my values and I sub it into that equation. So I might as well go into this one. R1 equals, now I'll go all three of them. So I'm using lambda as minus 1. 1 plus minus 4 lambda. Remember, lambda is minus 1. That's 4. I reckon 5. Next bit, 1 is minus 1 plus a minus 1. I reckon 0. And minus 3, oh, is minus 3 because the bottom number's got no lambda. So therefore, as a coordinate, that is 5, 0, minus 3. Notice it does say coordinate, so don't write it as a vector, write it as a coordinate. 5, 0, minus 3. There you go. Look, I've done it. Oh, apparently these, I've got the answer already on this one. I'm not convinced I've got time to show you this, but I'll start it anyway. Determine whether these lines are parallel, skew, or they intersect. Now, first of all, we've already seen that means that lambda is x plus 4. Lambda is y minus 3. Lambda is z minus 3 over 4. So I can rearrange this. And this is what I'm going to have to do. I mean, obviously, lambda minus 4 is the x. What does the y equal? It means lambda plus 3. And this one is 4 lambda plus 3 equals z. Now you want to try to write that in this consistent way. I'm going to write r equals. What's my point? My point here is minus 4, 3, 3 plus lambda. And then I do it for the other one. Lambda, how many lambdas have I got? Oh, I've got one of them, I've got one of them, and I've got 4 of them. Now that's got me one equation. I still need a second equation, saying r equals, done the same way. And I don't know why it says plus minus, so I'll have to have a check of that. I'll get that second equation, and then I've got to decide if they're parallel, skew, or they're intersecting. I wonder if there's an easier way using Cartesian equations instead. Either way, it says they do not intersect, they are skew. We'll look at that in class, and we'll look at this last equation in class as well, because I want us to do exercise 2C. Best of luck.